Today we'll talk about neural networks using PyTorch from scratch. So first we'll import required libraries and we will generate synthetic three-variable nonlinear data. It generates 100 data samples, each with three input features. This is generating three variables and generate 100 samples, three features, and then target is a nonlinear function, so all three variables plus noise. Then we'll convert NumPy PyTorch tensors. So here we are converting NumPy to PyTorch tensors, and then we define neural network from scratch. Um, yeah, so here we are doing that. Then first hidden layer, second hidden layer, and output layer. Then we'll instantiate the network, and then we'll define mean square error loss function. So we are defining that function here. We'll train the neural network after that. So here we are training the neural network, and at last we are printing it, and then we'll plot the graph. We are plotting a 4D plot. 4D visualization on non-linear regression data. Then we're plotting the loss curve. This is the loss over epochs. And then we're plotting the predictions versus true values, and then we'll iterate through features for scatter plots. So this is the visualization of it. Now we'll move on to neural networks using PyTorch with Lightning, PyTorch Lightning. So we'll install PyTorch Lightning first, then we'll import required libraries, and then we'll generate synthetic data for nonlinear regression. Here we are, then we'll convert NumPy arrays to PyTorch tensors, and we'll define the model with PyTorch Lightning. Here we are training with PyTorch Lightning trainer, as you can see, and after that we will do visualization, 4D visualization of model predictions. This is the 4D visualization, which is 3D input plus predicted output. Then we'll move on to neural network PyTorch using built-in modules. So for that we will import the required libraries, then as usual we will generate synthetic three-variable nonlinear data. Then we'll convert it into PyTorch tensor. Then we'll define three-layer neural network using PyTorch modules. Then we'll set up loss function optimizer. Then we will train neural network, and we'll plot the training graph. This is loss over epochs. Then we'll visualize data in 4D using 3D scatter plot. So this is 4D visualization of data. Then we will move on to NumPy implementation from scratch. For that, first we will do custom three-layer neural network for nonlinear regression using NumPy. This is the agenda of this Colab file. So for that we will import the required libraries, then we'll set random seed for reproducibility, then we'll define the function to generate synthetic data. This is generating the synthetic data, generate the training data and test data. Then we will do neural network implementation. For that we'll define various functions, and then we'll initialize the weight, and we'll do forward propagation, then backward propagation and training. So for that we'll do for backward propagation and then update parameter, and then training the function. Then we'll do model training and evaluation. Here we are defining the network architecture, and then we'll plot the graph of it, and then we'll evaluate the model. So you can see this is the graph of cost iterations, predictions, actual values, and we'll do 4D visualization. And as you can see, this is 4D visualization of model predictions versus actual values, and this after this alternative visualization to these slices. So this is visualization of 2D slices, two functions, two function, neural network prediction. Then we move on to TensorFlow. So we are doing 3 layers neural network for non-regression, non-linear regression, TensorFlow functional API. So first we import required libraries, then we set random seed for reproducibility. We'll generate synthetic data set and we'll generate the training and test data. Then we'll create the model using functional APIs and we'll create model instance, compile the model and create TensorFlow dataset and validate the dataset. We'll train the model. Then after that model evaluation and visualization. Here we will plot the graph. As you can see, this is the graph of training and validation loss and alternative visualization with tool slices. Again, we'll see that visualization of two function and neural network predictions. Then we will move on to TensorFlow built-in layers. So for that, we'll import the required libraries as usual. Set random seed for reproducibility, find function, generating data, generate training and test data. Then we'll create model using feeder layers, then create model instance, define loss function, and training loop, create data set, training batches, all that stuff. Then we will do model evaluation and visualization. They will plot different graphs here. As you can see, there is a graph of training loss over time and predictions of the actual values. After that, 2D slice visualization. So here we are defining one function to plot 2D slices. As you can see, 2D slices are here, two function neural network predictions. Then we'll move on to TensorFlow high level API. So as usual, we import libraries at random for reproducibility defined function. In this is the data generate, training and test data, and create model summary, compile the model, define callbacks, train the model. As usual, model evaluation, plot the graph of it. This is the graph, training validation loss, and training validation MAE. At last, we will move on to TensorFlow various variants. So for that, we'll import libraries, set random seed, define function, generate synthetic data, generate training and test data. Here we will define a class, name neural network TF, define the training set using gradient type, create model instance, create optimization, training loop, create data set. Same thing, plot the graph, training loss over time, create predictions versus actual value, 2D class visualization, two function neural network predictions. So these were all the Colab files of neural networks, NumPy, TensorFlow. So thank you so much for watching.